Alright guys, so welcome back. This is a continuation of our razor project. This video will show you the concepts I used to model the base plate of a safety razor. And again, the detailed drawings are available from the Electrical Engineering GitHub if you want to follow along. We are going to be using extrusion feature mainly for Fusion 360 for a bulk of the modeling. And we'll also be looking at how we can use hole features to assist us. This isn't a hard model or a hard item to model, so let's jump right in. Right, so as always, when starting a new model, it's best to save the work before you begin, just to make sure it's set up and correct. This model is a pretty simple extrusion in the main axial direction. So the first drawing we're going to draw is on the YZ plane. So we're going to draw a little box at the origin. Right, now we need to define our dimensions of this box. Those dimensions, again, will come directly from our drawing. Right, so in this case, the bottom dimension is 24.5 millimeters. And we're going to have a height of our piece of 5.75. And again, those come right from the drawing, so knowing how to read a technical drawing will assist you in pulling out these dimensions. If you're unsure about where I'm getting these dimensions, come by and see us here in the lab, and we can help you understand how to read technical drawings. So the bottom of our blade holder for safety razor here is curved. We're going to set that up by using a 3-point arc. Right, so a 3-point arc, you pick the two edges, and then you drag that third point in the direction of the arc. In this case, it's going to be tangent to that bottom line, so we'll go ahead and set that constraint up. So that arc is tangent to that bottom line, so it goes from wherever these points are on the edges to that tangent line. We're going to make those points vertical to each other so that that arc is constantly in the same plane, left and right, so that it is symmetric about the center axis. Here we see some interior drawings, right? So again, referring to the technical drawings, we're going to draw the side face of that middle piece, or that bottom, that piece that we've labeled number 2 in the technical drawing, the blade holder, right? Not really concerned about the dimensions just yet. I'm more of getting the overarching picture, making sure that it is symmetrical about the center axis here by making the left side and right side equal to each other in all aspects, and then making sure that stuff is horizontal and vertical where it needs to be, right? So making sure that everything lines up horizontally. Because we set up our drawing in such a way that everything on the left is equal to everything on the right, when we define dimensions for one object, it actually does change the second object. So you can see that 2.8 millimeter dimension on that straight piece did change the left and right side, as did all of the dimensions that we're currently adding. And again, these dimensions are coming directly from the technical drawing, so we are using the technical drawing as our guide and using intuition to figure out what these dimensions are if they're not explicitly stated. And we're just going through and dimensioning all the points. Remember, once a line is fully dimensioned, fully constrained, it turns to that black color, so it can no longer be moved in any direction. And then the lighter blue lines are unconstrained in one or more directions. So the goal of creating these dimensions at this time is to make sure that those lines are where they are dimensioned properly, so that they are fully constrained, so that there's no ambiguity about where they're located in space. One of the interesting things that you can do with dimensions, right? So here we have a dimension of 8.625. One of the things that you can do is you don't necessarily have to put a number in there, right? You can use other dimensions. So you'll see here, I am searching down for this length, this full length dimension. I see that it's already been made, right? So let me delete that real quick. Right? So it's a little bit off. It's off the screen just a little bit, and here we go. You got to find it and pull it up. So once you've put that dimension, make sure you can actually see all your dimensions in your drawing in the frame that you're looking in, right? So there's the other one. I'll pull it in because I'm going to need that later. right? But let's say I want to put this vertical line for this in-cut section here. I want to make sure it's halfway between these two, right? I can literally just take that dimension, and instead of typing it out, I click on the dimension I want to do, right? And I want to remove the space that that line takes up, so D1 minus D11. And then if I divide that by 2, that distance is defined as half that space, right? So you can do math inside of your dimensional spaces, right? They don't have to be solely numbers. Right? So you can make dimensions equal to each other simply by clicking those dimensions inside of that dimensional dialog box. So we're going to add 3-point arc here. Remember, this 3-point arc is going to interface with the other piece that we're going to create in the next video, the head of the razor. Making sure that those arches line up is important to the fit and finish of our razor. Also notice that as I'm going through here, this is not fully defined because those lines are not yet black. Even when I put this dimension on here for the arc length or the arc radius, it makes the arcs defined, but it doesn't make that inset piece defined. So we need to define all the directions of that so that it is completely defined on all dimensions. So once you're done with your sketch, finish your sketch. Now we're going to extrude just that interior outline, which will create our new part, the razor head base. Right, so we're going to extrude that the distance given on the technical drawings, which is 41.1. Here's our piece so far. Right, so notice that it doesn't have any holes in it, doesn't have any cuts in it. Okay, so we're going to need to add those. So we're going to add a sketch on that interior inset face. To add a hole, remember it's very simple to add a hole. All you have to do is create a point and then define where that point is. So we're going to create our point and then define how far away they are. Once you've defined your points, you can make a hole by clicking on them and creating a hole feature. Remember, we need to think about what type of hole we're going to create. Remember, we're trying to pass a 4mm rod and a M4 threaded section through these holes. They're locating holes, so we need to go to, and we're going to go to the actual piece that we have so that it'll go all the way through. So we're going to click on the object that we're going to cut through. And then we also need to make sure that they're clearance holes and that they're clearance for M4. That is a 4mm metric hole. It's the size of threading that we have for the top part. Once we have our holes cut, we need to think about cutting the gullet. That is the part of the razor blade that actually lets you get the hair and things that you're cutting out of the blade's path. Right? This is that inset section inside of a razor blade holder. Okay, so it's going to go on that flat section, same plane as the holes, but it's a different section. It has a little bit of a ridge between them. Okay, so we're going to draw on that plane. We're going to project the geometry of the plane onto our drawing. And then we're going to just draw a triangle, or I'm sorry, a rectangle that represents the gullets that we're going to cut in that rectangular space. And remember, we want to have symmetry from top to bottom in this case. So we're going to make everything equal, make sure that it's all properly symmetrical. And we're going to use a fillet tool on all the corners. A fillet is a fancy way to say rounding off that corner. We're going to round it off with a 1.5mm rounding. Right, so again, looking at our drawings, we know that we need fillets based on how the drawing is and where our fillet callout is on our drawing. Once we have that rounded over, we can define the size of our rectangular space to cut and where the edge location is. Once we've finished our drawing, it's on to the last feature that this object has. We're going to cut that gullet all the way through the part, right? So distance 2, and then we're going to make sure that everything looks proper. Looks like the drawing. And once we are all finished, here is our final razor part. This is the blade holder for our safety razor. So we'll go ahead and save that. And notice that when we save it, it updates the version number. We don't necessarily need to put a description. Sometimes descriptions are nice in saving. Right? But that is our razor blade holder. Right? So this is another part for our razor. And then we will finish this up next video. We'll we'll model the top cap, and then we'll show how to put the razor together in Fusion 360 and how to create the technical drawing that you're looking at on the GitHub page if you are following along with that. And then ultimately we'll show how to create this as a physical object, both 3D printing and, because we have the ability here, we will CNC it out of copper. Or, I'm sorry, we'll probably do it out of brass. Right? So that is all coming up in another video, and I will see you in another video.